Okay, so yesterday you worked on what are called compound events. For example, if you wanted to say, what's the odds of drawing the purple marble, which is going to be 1, sorry, a little pen issue, 1 out of 8, and then drawing the red marble, which is going to be 1 out of 8. So that means that my probability of drawing the purple and then the red is 1 out of 64. All right, so here's the difference today. What we want to work on today is we want to work on what are called independent and dependent probability. So let's go back to the marbles again. What you just did is you heard me say, I'm going to try to draw the purple, I'm going to put it back, and then I'm going to draw the red. If you put an object back, or you can use it more than once, that's independent. Now, dependent is a little different. So let's say this time I'm going to draw the purple, which is still a 1 out of 8 chance. I'm not going to put the marble back in this time. Now I'm going to try and draw the red. So if I don't put it back, the probability of drawing the red is now 1 out of 7, because there's only 7 marbles. So what's my probability of going purple then red? 1 out of 56. And then, of course, I can convert that into a percent if I want. Okay? So what we want to do is identify whether some items are going to be independent or dependent. So let's start with this first one. You roll a number cube twice, you get a 3, and then you roll it again. And it's an odd number. You didn't do anything different. You used the same die both times. That means these are independent events. You flip a coin twice. The first flip is heads. The second flip is tails. Same coin. You didn't do anything different. Independent event. You randomly draw a marble that has 3 red and 5 blue. You keep the marble you drew and then draw a second. Well, because you took one out and you're not using it again, that one is dependent. And number 4, you randomly draw a marble, 6 red, 2 blue, you put it back, and then you draw a second marble. Well, since you put it back, you can use it again. That means it's an independent probability. Okay, so let's go here. You've got a lock, and it goes from 0 to 9. I'm going to get rid of this because we're going to change the question just a little bit. So your friend comes up to you, and they say, hey, I bet I can guess your locker combination. If you can reuse the numbers, and you're going to use 0 to 9, that means that there's a 1 in 10 chance, a 1 in 10 chance, 1 out of 10, and so there's 1 out of 1,000 that they can guess your locker combination. That one, independent, because you can reuse it. So let's talk dependent, though. If you're using 0 to 9 and you cannot repeat a number, you still have 1 out of 10 for the first one. But the next time, you can't use one of them, so now you're down to 1 over 9. The next one, now you're out of these, 1 over 8. And that means you're talking about a 1 out of 720 chance that they can guess it. Still pretty high, but it does change your probability. Okay, let's look at this. And let's just go ahead and go dependent. Let's say that I want to know the probability that I can draw the L and then draw the R. So for the first one, if I want to draw the L, I got a 1 out of 7 chance. I don't put it back in. Now I have a 1 out of 6 chance to draw the R. So my probability of going L then R with not putting it back is 1 out of 42. All right. Real world application. You're on a game show. Woo! There's 100 people in the crowd. You're with 5 of your relatives and then 6 other friends. What's the probability that you get a relative chosen first and then one of your friends? Well, it's going to be independent. So, no, I'm sorry, dependent. It depends on who you get the first time. So, you are looking at a 5 out of 100 chance that one of your relatives gets picked. So the relative gets picked. Now you're down to 6 friends, but since it's dependent, are there still 100 people? I see you shaking your head. You are correct. There is not 100 people. There are now 99. What's the probability that that happens? Well, I can simplify these to make my life a little bit easier. So this is going to break down to 1 over 20. This could break down to 2 over 33. You could do this. So what's the probability that that happens? One of your relatives and then one of your friends? It's going to be 1 out of 333. Okay, just remember, independent probability is the same chance each time. Think about it like putting the marbles back. A dependent probability means that you're going to keep something out or something cannot be repeated. Okay, good luck.